This video is about significant figures and their rules. So why should we care about sig figs? Well, because they give us more accurate answers by helping us know where to round or when to use standard notation. Sig figs also give a sense of how accurate a measuring tool is. For example, this top ruler is not the best because there are few accurate markings, which means less significant figures. The bottom ruler is more accurate with more notches, which gives us more certainty, therefore more sig figs. You might be wondering what a significant figure is. It is all certain numbers plus one uncertain. Scientific notation is useful for showing sig figs when a number is either really big or really small. Here are some examples. Okay, let's move on to some rules we must follow when determining the number of sig figs in a measurement. The first rule is all non-zero digits are significant. Here are some examples. The second rule is internal zeros or zeros between numbers are significant. The third rule is trailing zeros or zeros to the right of non-zero numbers that follow before or after a decimal point are significant. However, trailing zeros without a decimal point present are not significant. The last rule is leading zeros, or zeros to the left of the first non-zero number, are never significant. Alright, now you try. How many sig figs are in each measurement? Pause the video if needed. The first has a trailing zero with a decimal present, the second has two trailing zeros with no decimal, and the third has a decimal, so the zeros are counted in the sig figs. Now that we have gone over the sig fig rules, let's review the rules involved with sig figs in calculations. This first rule is for multiplication and division. The answer must have the same number of sig figs as the input with the fewest number of sig figs. Here's an example. Start off by counting the number of sig figs in each number, then multiply or divide, then either round up or round down. The input with the smallest number of sig figs has 2 sig figs, so the answer must also have 2 sig figs. Okay, now you try this one. Again, pause the video if necessary. Count the sig figs, then multiply and divide, and then determine the number of sig figs. This next rule is for addition and subtraction. The answer must have the same number of decimal places as the input with the fewest number of decimal places. Stack the numbers by lining up the decimal places so you can see which has the least. Draw a line so it's clear. Add, then round as necessary. You try this one. First add and keep track of the sig figs by drawing a line under the last sig fig. Then subtract. And then round. This last rule is for both multiplication and division and addition and subtraction. Complete the parentheses first, then determine the correct number of sig figs without rounding, solve the rest of the equation, and deal with the sig fig rounding at the end. In this example, we would do the subtraction first, then the multiplication, and the answer would have 2 sig figs. Just a quick note before you try one. Remember to keep track of the sig figs throughout the problem and round only at the end. Now, here is a problem that you can try. Again, pause if necessary. Take note of the sig figs at the beginning. Do the parentheses first, which is multiplication. Then do the rest and round at the end. Well, that's all I have to say about sig figs. I hope it helped you understand them more, and thank you for watching.